So in this video, we're going to explore a little bit more about how the a value affects the quadratic. Right here I have the parent function graphed, and as you can see, the vertex of the parent function is 0, 0, and the first 2 points it goes through are 1, 1, and negative 1, 1. So it goes over 1 and up 1, and then over 1 and up 1 this way. So what makes this little triangle right here, that's the parent function. We know that when we have a number in front of the parent function, that it either makes it wider or thinner. So if we graph the function 2x squared, the number in front is greater than 1, so it's going to make the new function thinner than the parent function. Now our vertex is still at 0, 0 because we have no horizontal or vertical change. So our vertex is at 0, 0, but where are our next 2 points? On the parent function, they were over 1 and up 1. Well, this is multiplied by 2, so instead of going over 1, up 1, we have to multiply by 2. So we're going to go over 1 and up 1, 2. And there's our next point on our quadratic. And then we'd go the opposite way. We would go negative 1 up positive 2. So if we look at one that is wider, we know that a number between 0 and 1 makes it wider, so 1/3 would make this graph wider. So it is wider than the parent function. So instead of going over 1, up 1, we would have to multiply that 1 by 1/3, so it goes over 1 and up 1/3. That point right there is 1/3. And it's kind of an estimate because this whole thing is 1. Half would be right in between there. So that's at about 1/3. And we would go over negative 1 and up 1/3. So that's kind of how we can graph that a transformation. So if we look at f of x equals 5x squared, the a is greater than 1, so it's going to make this graph wider than the parent function. Our vertex is at 0. So if we were going to graph this by hand, let's graph some points. And I'm going to just pick a point. And I know that my vertex is at 0, 0. So I'm going to put that point right there. Now, like the parent function, it would go over 1 and up 1. And there would be our first point. But this is multiplied by 5. So instead of going over 1, up 1, we're going to go over 1 and up 5. So there's 1, 2, 3, 4, 5. And there would be our point. And it would be the same on this side because the quadratic is symmetrical. So over negative 1, 1, 2, 3, 4, 5. And we'd have that point there. So if we want to see if that's correct, going to go ahead and graph that. So we have 5x squared, and we will see if it goes through the points. And you can see it goes through those points right there. So let's look at another one. Here we have a negative 3. Then, as you have learned, the negative just makes the quadratic open down. It reflects it over the x-axis. The 3 is still greater than 1, so it will make it thinner. So our vertex in this case is still 0, 0. So we're going to graph our vertex at 0, 0. And we know it's going to open down. So we know our next points are going to be down here. So our parent function would be over 1, down 1. But this is multiplied by 3, so we're going to go over 1, down 3. 1, 2, 3. And then it's symmetrical, so we go negative 1, 1, 2, 3. So let's put our equation in, and see if those match. Negative 3x squared. And so our equation goes through those points that we graphed. So if we have a equation that we know is going to be wider than the parent function, in this case our vertex is still 0, 0. So we'll go to geometry and graph our points. So our vertex is at 0, 0. It is positive, so it opens up. Now on this one, our parent function would go over 1, up 1, but this is wider. So it's going to be between here. So we would have to multiply it by a half. So we would go over 1 and up approximately a half. Now this isn't going to be exact. And we would do the same thing on this side. You could fix your scales on your graph if you needed to be positive. But let's look and see if that goes through the points that we put on there. So we have 1/2 x squared. And there it goes through our points. So that's how you graph the a value after you've found the vertex.